Hello everybody. Today we're going to talk about solving equations with parentheses and like terms. So when solving any equation, most of the time, and when I say most of the time, probably about 95 to 97% of the time, because there's always those exceptions in mathematics, you guys know that. But usually you almost always want to distribute. So if you have parentheses in your problem, you would distribute the term on the outside to every term on the inside of the parentheses only. If there's any other remaining terms, you would then bring them down. And your second step is then to combine like terms on each side of the equation. So I always, especially now that the equations are getting larger for you guys, I always draw a line through the equal sign because it separates your two sides. And you want to combine your like terms on each side of the equation. And these two steps right here are going to be so critical for the future. You always want to check for them first. I like to call them DC, just like our nation's capital. So distribute, combine like terms on each side. And your third step for right now, we'll call this solve, because for today it's going to be a two-step equation, but in the future it could be something else. So for today we're just going to say solve. But again, when we're talking about solving the remaining part, this will be a two-step equation. So you're going to isolate the term with the variable, and then you're going to isolate the variable completely. So let's look at some examples. So for our first example, we have 3 times the quantity, x minus 2 minus 7 equals negative 28. So you had a problem like this in one of your last assignments. I think I actually gave you 2 like this, even though we didn't talk a lot about it. I just want to see how you did with it. But your first step is always going to be to distribute. So we have parentheses right here. So we're going to distribute the 3 to each of the terms inside the parentheses. So we get 3x minus 6. That's all distributing we do. Now at this point, anything else that's remaining to help us stay organized, we just bring it down. So I rewrite the minus 7, keep it on the left side. Rewrite the equals negative 28, keep it on the right side. For your second step, now you combine like terms. So we just have a number on the right-hand side. On the left-hand side, we'll look to see if we have any like terms. And we do. We have these two integers, negative 6 and negative 7. So we're just going to add them together. Remember, when you're combining like terms, don't write anything underneath the problem. We're just joining these two together. So 3x, and if I add those two up, we get negative 13. Okay, so distributing and combining like terms are the only two steps really that you do on the respective side they're on, because you're not actually changing anything in the problem. You're just alternating its form. Okay, so we're just combining these two things that are similar. It's kind of like very similar to like if you had change in your pocket and you put all your dimes together and all your nickels together. It's just like that. Okay, so now we have a two-step equation left. 3x minus 13 equals negative 28. So we got to isolate the 3x, so we'll add 13 to both sides. 3x, and then we're adding a positive and negative, so we're going to subtract. Keep the sign of the larger number, negative 15. Last step, divide by 3. X equals negative 5. And then remember, just like before, you can always check this answer. If you want to plug it in, do order of operations, let's try that. So negative 5 minus 2, that's going to be negative 7, right? Negative 7 times 3 is negative 21. Negative 21 minus 7 is negative 28, so it does check out. You remember, you could always check your answer by taking your solution and plugging it back in for the variable and using order of operations to see if the left equals the right. We're not going to check every single problem from now on for the remainder of the lesson, but it's always a good idea if you're in doubt or if you have extra time when you finish a test or a quiz to check your problem by substituting it back in. All right, so let's look at another example. So we have 73 equals 5 minus 4 times the quantity 2x minus 1. Well, first let me say I'm going to leave the equation the way it is. But if you really wanted to, if this confuses you the way it's set up, you could actually take this equal 73 part and put it over here. Because an equation is a mathematical statement indicating the left-hand side and the right-hand side are equivalent. So you could always basically switch the sides. Now again, I'm going to solve the original, it doesn't matter. I'm going to solve the problem the way it was presented to us originally. But I just want to make that point in case you like that better. So I'm going to draw a line through the equal sign. Now look at that equation for a second. Ask yourself what you would do first. So did everybody think about that? Well, I'm going to ask you right now, how many people today were going to do 5 minus 4? Guess what? That is incorrect. I know it's very, very tempting because it's kind of separated by the parentheses and they're both numbers, but that would be the complete incorrect process to solving this equation. Multiplication takes a priority over addition and subtraction. So you actually want to distribute first. Remember, that's your first step on slide 1. Distribute. So anytime we have parentheses, we want to distribute, right? That term on the outside to every term on the inside. So we take this negative 4 and we multiply it to the terms inside the parentheses. So I'll bring down this 73, bring down the positive 5, and we distribute the negative 4, we get negative 8x plus 4. After we distribute, now we look to combine like terms. So we just have 73 on the left-hand side. We have two integers right here. Those combine to be positive 9. And by the way, it doesn't matter whether I put that positive 9 first or I put the negative 8x first. As long as I include the sign to the left, that's mathematically equivalent. So I'll just put negative 8x first plus 9, or I could actually wrote that as 9 minus 8x, which would be exactly the same thing. Because the 9 would still be positive, the 8x would still be negative. Okay? But now we have a two-step equation left. So we subtract 9 from both sides to isolate the term with the variable. 73 minus 9. 64, right? You don't have to borrow to do that one. Okay? Bring down to negative 8x. Last step, divide by negative 8. X equals negative 8. Awesome. Remember, if you want to check it, you could plug it in back here. I would do the parentheses first. So, and again, negative 8 times 2, that would be negative 16, right? Minus 1 would be negative 17. Then we'd actually do negative 17 times the negative 4. That becomes a positive 68. And then positive 68 plus 5, that would in fact give you 73, so it does check out. So here's one of our last guided examples. Now remember, if I'm ever going too fast, just stop the video. You want to go at your own pace, right? So we have 2 times the quantity x minus 7 minus 3 times the quantity 5 minus x equals negative 34. So you follow your steps. First thing you got to do is distribute. So we're going to distribute the 2 here and get 2x minus 14. And now we distribute the negative 3 to the second parenthesis because it's touching now or being multiplied to it. We get negative 15 plus 3x. Negative 3 times the negative x is a positive 3x. I know that equation may have looked very large at first, but it's not that bad, right? Now we combine our like terms. So we actually have 2 sets of like terms for this problem. We have a positive 2x and a positive 3x. We add those up, we get 5x. Okay, maybe you want to cross them off so you know you add them together. And now we have our two integers, negative 14 and negative 15. We add those up, they're both negative, negative 29, excuse me. And that equals negative 34. If it helps you could draw a line through the equal sign. Now, that's not a straight line, but you get the idea. I could always just move this over. If that bothered you what I just did, I could just move it over a little bit, right? So, is that better? And then you get negative 34 here. So you could, if it helps you, which I think it's a great idea for a lot of you, to draw a line through the equal sign to separate your two sides. And now we can start doing things to both sides. So we add 29 to both sides to isolate the 5x. Negative 34 plus 29 is negative 5. Last step, divide by 5. X is negative 1. Awesome. Okay, so here's 2 problems for you to try to finish the lesson. So copy these down in your notebook. Answer them on a separate sheet of paper. So at this point, pause the video. And the next 20 seconds will be blank. And restart the video when you're done. All right, so hopefully you got the opportunity to do those on your own to get the most out of this lesson. So first thing we do for the first one is distribute. So we get negative 40x plus 24, right? Negative times negative is positive there. Minus 23 equals 11. Second, we combine our like terms. Those combine to be positive 1. Be careful of your signs. Okay? And now we have a two-step equation left. I might have to finish up here because I'm out of space. We'll subtract 1 from both sides. So we get negative 40x equals 10. Last step is divide by negative 40. So you might be saying, uh-oh. Hopefully you didn't write an answer of negative 4 there because 40 can't go into 10. So what you got to do is reduce, all right? And we could divide the numerator and denominator of that by 10. So 10 divided by 10 is 1. And then 40 divided by 10 is 4. And since one of these numbers was negative, our final answer is negative. So our final answer for this one is negative 1/4. That's a great reminder that when you're solving problems in algebra, not every problem is going to work out to be an integer, okay? If it doesn't work out to be an integer, one of the best things you could do is leave it as a fraction in lowest terms. And then finally, the second one of the reasons I gave this one to you is there's no parentheses. So if there's no parentheses, you go on to step 2, which would be to combine like terms, right? So these two combine, negative 20x and 16x, positive 16x, to be negative 4x, right? And now we solve the two-step equation left. So we subtract 2 from both sides. Negative 52 equals negative 4x. Last step is to divide by negative 4. And you might have to write that one out or use your calculator. But 4 goes into 5 once with a remainder of 1. And then 4 goes into 12 3 times. So that would be an answer of positive 13. Okay, positive 13. So there you go, guys. Hopefully you found this video lesson helpful. If you had any questions, you might want to rewatch the video. But if you have any questions about anything that was done, please send me an email. Thank you very much for your attention, as always, and have a fantastic day, everybody.